Welcome guys to another section of our math tutorials. Today we will be looking at matrices, but before then, if you are new to the channel or you've already been watching our videos, kindly like, subscribe, share with your friends. Also, if you have any suggestions, kindly write it down in the comment section. As I said, today we will be looking at matrices. When you say matrices, by simple definition, matrices is any elements such as variables, numbers, or parameters enclosed in a bracket. So assuming you have this, you have 2, 3, 4, and 5, and you enclose this in a bracket. You can term this as matrices, or assuming as the definition goes, any numbers or variables. So we have x, y, z, or let's say a. This is also termed as a matrix because it has been enclosed in what? In a bracket. So we have 2, 3, 4, 5 as a matrix. We have x, y, z, a as also what? Matrix. So matrices is basically any element enclosed in a bracket. We can also say that matrices is the rectangular array of elements arranged in rows and columns. From the board, we can see that we have 2, 3, 4, and 5. And by this, each element, we have 2 as first elements, 3 as second elements, 4 as third elements, and 5 as third elements. So element 1, element 2, which is 2 and 3, is termed as the first row. Whilst the second column is, the first column is 2 and 4, and 3 and 5 is the second column. So any element which is arranged in rows and columns can also be termed as what? As matrices. Why do we then study matrices? We study matrices for us to help, or it helps us to solve complicated linear equations. There are certain equations of which you can't use the, the substitution method, the elimination method in linear equation, but with the help of matrices, you can solve these particular equations at easy pace. We can talk of equations involving 3 variables or even more than 3 variables. Let's have this equation: x plus y plus z equals 10 as equation 1. Then equation 2 to be 3x plus 2y plus z equals 3 as our equation 2. Then our equation 3 to be 3x plus y plus 4z equals 3. So having this equation, one may decide not to go or use substitution or elimination method to solve this particular linear equation, which is involving 3 variables, x and y, x, y, and z. But with the help of matrices, either matrices inversion, that's inverse of a matrix, or the Cramer's rule, you can solve this particular equation at an easy pace without even going through huge procedures or huge steps. Matrices are defined by their dimensions in the sense that we have this particular matrix which is 2, 3, 4, and 5. So this is a typical 2 by 2 matrix. It is defined by their rows and columns. Elements in the first one, which is 2 and 3, is the first row. 4 and 5 is the second row. So this elements or this particular matrices is a 2 by 2 matrices or a 2 by 2 square matrices. So we can also have this particular matrix which is 1, 2, 3. This is also a matrix. Assuming this is matrix A. So this is a matrices. How do we then define these matrices? As I said, it is defined by their dimensions. So we can see that we have one row, one column, 2 column, and what? 3. So this particular matrix is having what? 3 columns, but has a single row. So in that case, this particular matrix is called, or this particular matrix is defined by 1 by 3. So this is a 1 by 3 what matrices, or a row matrix. As I said, it is defined by their dimensions. Now let's look at types of matrices. We have about 3 types of matrices. It's more than 3, but we want us to look at either 3 or 4 matrices. We can talk of row matrix, column matrix, square matrix, diagonal matrix, and rectangular matrix. So we have row matrix, column matrix, we can talk of square matrix, diagonal matrix, and also the last one, which is rectangular matrix. So these are the types of matrices that I want us to look at. So let's take them one after the other. Now, the row matrix, as I said earlier, a row matrix is simply a matrix which has only one row but multiple columns. So we can have 1, 2, 3 as the example that I gave. So you can see that it has multiple columns. That's first column which is 1, second column which is 2, then third column which is what, 3, but a single row. So by the definition, matrices are defined by their dimension. So you can say that this particular matrix is what? It's a 1 by 3 matrix because it has what? Only one row. So this matrix is defined as what? 1 by 3 what? Matrix because it has what? A single row but multiple what? Columns. Now let's look at the column matrix. As the definition or as I define the row matrix, the opposite of this row matrix is what? It's a column matrix. Now the column matrix is just turning this upside down. So we have 1, 2, and 3. So this is an example of what? Of a column matrix. So this particular matrix, it has what? Multiple rows, but what? A single column. Multiple rows as in, this is the first row, the second row what? And the third row, but a single column. That's 1, 2 what? A single column. This is the single column. So this particular matrix is also defined as what? A 3 by 1 what? Matrix. It's not the same as the row matrix as you see here. Matrices are defined by rows and columns, and not columns what? By rows. So from the first example that I gave under the row matrix, we have it was 1 by what? 3 because it has a single column. Sorry, a single row. But the second one, which is under column matrix, it has what? Multiple what? Rows, which is 3 rows. So you have 1, 2, 3. So by the definition I give, defined by their what? Dimension, which is rows by column, we can say that this particular matrix is defined as what? A 3 by 1 what? Matrices. Now let's look at the square matrices. A square matrix is basically a type of matrix that has all their elements to be equal. Now let's look at a square matrix. Let me give an example so that we define this square matrix by its example. So we have 4, 8, 5, 3. So this is a square matrix. A square matrix is basically a matrix which has all the elements, that's the rows and columns, to be equal. So from this example, you can see that it has what? First row and second row, and first column and second row. So for square matrices, the rows and columns are the same. That's for square matrices. And by the definition, this is a typical 2 by 2 matrix or a 2 by 2 square matrix. Either 2 by 2 matrix, you are not wrong, or square or 2 by 2 square matrices. So for square matrices, all the elements, that the rows and columns are the same. You can see that we have 2 rows and 2 columns. So this matrix is defined as what? A 2 by 2 matrices. Now let's look at diagonal matrix. Diagonal matrix is a square matrix. Please, do you get what I'm saying? Diagonal matrix is a square matrix that have its element of the principal diagonal to be 0. I will give an example for you to get the definition. But before that, let's get what I'm saying. I'm saying that diagonal matrix is a square matrix that has its element of the principal diagonal to be 0. So let's look at this example. We have this 1, 0, and 0, 1. So this is the principal diagonal, as the arrow indicates. So this is the principal diagonal. And the definition that I give, I said that it's a square matrix that have its element of the principal diagonal to be what? To be 0. So you can see that this is the principal diagonal, the 1 and 1. The element of the principal diagonal, that's the other diagonal or the leading diagonal, is what? Is 0. So by the definition or by this example, you can say that diagonal matrix is a square because it is a 2 by 2 matrix because it has 2 rows and 2 columns. So any element or any matrices that has its element of the principal diagonal, that's the first diagonal of the one or the principal diagonal to be 0 is termed as what? A diagonal matrices or a diagonal matrix. Let's look at the last type of matrices, that's rectangular matrix. Now, rectangular matrix is any matrix that has the number of rows and columns not to be the same, that's an equal number of rows and columns. So assuming we have this matrix 2, 5, 12, 6, 18, and 20. So assuming you have this particular matrix, that's assuming this matrix A. This is a rectangular matrix because the number of rows is not equal to the number of columns. By definition, we have a 2 by 3 matrix because we have the first row and the second row. And what? We have 3 columns. That's the first column, which is 2 and 6. Second column, which is 5 and 18. Third column, which is what? 12 and 20. So rectangular matrix is not like the square matrix, which has the number of rows and columns to be the same. For rectangular matrix, the number of rows is not equal to the number of columns. So this is a typical example of what? Of a rectangular matrix. From here, we'll be looking at addition and subtraction of what? Matrices. Then we move to multiplication of matrices. Now let's look at addition and subtraction of matrices. Addition and subtraction of matrices. Two matrices can be added or subtracted when they are of equal dimensions. Did you get what I said? I said two matrices can be added or subtracted when they are of equal dimensions. As I explained earlier, dimension means rows by what column. That's the first matrix and the second matrix. They have to be of equal dimensions. That the number of rows in the first matrix and the column has to be the same as what the second matrix. So let's look at this example. Assuming this is our matrix A, we have 2, 4, 10, 5. Then matrix B to be 3, 1, 2, 7. So we have these two matrices, matrix A and matrix B. Now it says that two of these matrices, we can add or subtract them when they are of what? Equal dimension, in the sense that this is what? A 2 by 2 matrix. This is also what? A 2 by 2 matrix. Now you can't add a 2 by 2 matrix to what? A 3 by, assuming this was to be a 3 by 3 matrix, that's a rectangular matrix. That's let's extend this one to 5, then let's say 10. 2 by 2 by 3 matrix. Now the property says that you can't add or subtract this particular matrix because they are not of equal dimension, in the sense that this is what? A 2 by 2 matrix, and this is what? A 2 by what? A 3 matrix. So you can't add or subtract this particular matrix. When you get to multiplication of matrices, we can also we can perform such matrices, that you can multiply this particular matrix. But before then, let's look at addition or subtraction of matrices. So the example that I gave earlier, that's 3, 1, and 7. We can add these two matrices because of they are of equal dimension. Now, how do we then add or subtract this particular matrix? So let's find A plus B. That's matrix A and B. So the question says we find A plus B. How do we then find B? Now that we know that they are of equal dimension, how do we then add or subtract them? The question says we should find, or we should add matrix A to matrix B. As I said, you can only add or subtract because of because they are of equal dimension. That the number of rows and columns in the first matrix is the same as the number of rows and columns in the second matrix, which is matrix B. Now, how do we then add A to B? Since we know that they are of equal dimension, you can only add them. You cannot add this matrix or element A to element this third element in matrix B. No, we don't do it that way. You can only add and subtract their corresponding matrices or their corresponding elements. So we have 2, which we are going to add it to 3 because it is corresponding. Please do get what I'm saying. You cannot add these 2 to the one here. They are not corresponding. It is the 4 here which is corresponding to To the 1 at the back. But the 2 here correspond to To the 3. That's the first element. So we have to add 2 to 3, then 4 to 1, then we have 10 to 2, then 5 to To 7. Now this is how addition of matrices is done. You cannot add these 2 to the 7 here. No, we don't do it that way. We add and subtract the corresponding elements or the corresponding items. So since we know our corresponding item, that's the 2 goes to 3, 4 goes to 1, 10 goes to 2, then 5 goes to 7. As you've seen it here, this is what we now have. So since we know what we have our element, that's our third one. Now we then do our addition. So 2 plus 3 gives us what? Gives us 5. 4 plus 1 gives us what? Also 5. Then 10 plus 2 gives us what? 12. Then this is 12. So now we find what? A plus what? B. So this is how addition of matrices is done. So this is also what? A 2 by 2 what? Matrix. I want us to use this same example to solve the subtraction of what? Matrix. So we have, so let's change this one, the operation sign to what? To minus. It goes by the same approach as the first one, which is we are going to add or subtract what? Their corresponding elements. 2 correspond to 3, 4 correspond to 1, 10 correspond to 2, then 5 correspond to what? To 7. So if you want to do our subtraction, we have our 2 minus the corresponding element, which is what? 3, then 4, the corresponding element, which is what? 1. We have 10, its corresponding element to be what? 2, then 5, its corresponding element to be what? To be 7. Now you do your subtraction. So 2 minus 3 gives us what? Minus 1. 4 minus 1 gives us what? Positive 3. 10 minus 2 gives us what? 8. Then 5 minus 7 gives us what? Minus 2. So this is what? The matrix. After subtracting matrix B from matrix A, we have what? Minus 1, 3, 8, then what? Minus 2. So we have our what? 2 by 2 square matrix or 2 by 2 what? Matrix. We are now going to look at scalar matrix and what? Matrix application, multiplication of what? Matrix. Now let's look at scalar matrix. Scalar matrix. So scalar matrix is basically multiplying every element in the matrix by a single number called scalar. So we can have 2 multiplying what? Let's say 5, 8, 3, and 4. So this particular number here, which is 2, is termed as what? As the scalar. So scalar is basically multiplying every element in the matrix by a single number outside the matrix, what's called the scalar. So if you multiply this number, this 2 is called what? The scalar. So multiplying this 2 by this whole matrix is called what? Scalar multiplication. So if you multiply 2 by this particular matrix, we are going to get 2 multiplied by 5 gives us 10. 2 times 8 gives us what? 16. 2 by 3 gives us what? 6. 2 by 4 gives us what? 8. So the process which we are multiplying the scalar, which is the outside number, by the matrix is termed as what? Scalar multiplication. So we have 2 by 5, we have 10. 2 by 8, we have 16. 2 by 3, we have 6. Then 2 by what? 4, we have what? 8. Now let's move quickly to multiplication of what? Matrices. Multiplication of matrix is not like addition and subtraction of matrix, where for addition of matrix, you have to, the rows and columns in the first matrix has to be the same as the rows and columns in the second matrix. For multiplication of matrix, you can have a 2 by 2 matrix multiplying a 3 by 2 what? Matrix. So let's look at this example. Or before the example, multiplication of, you can only multiply matrix A by matrix B when they are conformable. You can only add addition and you can only multiply 2 matrices when they are conformable, in the sense that the number of columns in the first matrix, which is, let's say, matrix A, should be the same as the number of rows in the second matrix, which is what? Matrix B. Now let's look at this example. Assuming we have 3, 4, 6, 2, 1, 0 as our matrix A, then matrix B to be 1, 2, 3, 4, 5, and 6. So by dimension, we have a 2 by 3 matrix, which is a rectangular matrix. Then we have 1 row, 2 row, then what? Third row. So we have 3 by what? 2 matrices. As I said, matrices are defined by what? By their dimension. So this matrix is what? It's a 2 by 3 matrix, whilst matrix B is what? Matrix B is what? A 3 by 2 what? Matrix, because it has 3 number of what? Rows and 2 number of columns. Now the principle of multiplication of matrices states that we can only multiply these 2 matrices when they are conformable, in the sense that the number of columns here, we have 1, 2, 3. The number of columns in the first matrix, which is what? Matrix A, should be the same as the number of rows in the second what? In the second matrix, which is what? Matrix B. So we have 3 columns here. That's first column, second column, and what? Third column. Now it should be the same as the number of rows in the what? In the second column, which is what? Sorry, in the second matrix, which is what? Matrix B. We have first row, second row, and what? Third row. Once that you know that, oh, these two matrices are what? Are conformable. Now you can go ahead and what? And do your multiplication. Now let's go ahead and do our multiplication of this one, this particular matrix. Now we are going to multiply this particular matrix, this particular element, which is what? Element 1 by this one. So we have 3 multiplied by 1. Then go by another one. We have 4 multiplied by what? By 3. Then we have 6 multiplied by what? Multiplied by what? 5. So let me put it this way. You are done with your first part. Now you take this first element again, you multiply by what? By the second element in the matrix A, sorry, matrix B. Don't forget, you multiply this by that, this by that, 6 by 5. After that, you go to the second column in the matrix B. But you also use the same what? The first row, which is 3 by 2. So let me write this in a simple way so that you can get enough space and do the second one. We have 3 by 1 plus 4 by 3 plus 6 by what? By 5. Now let's move to the second element. So we multiply this 3 by 2. So we have 3 multiplied by 2. We are not going to add. Plus, we have 4 by 4. So we have 4 by 4. Then we add, we have 6 by 6. So because of space, pardon us for that. 6 by 6. Now you are done with your first what? Your first row. Your first row. Now let's look at the second row. Same approach. You multiply this 2 by the 1 here. So you have 2 multiplied by 1 plus the second one, which is 1 multiplied by 3. We have 1 multiplied by 3. Then 0 multiplied by 5 plus 0 multiplied by what? By 5. You are done with your first element. Now let's move to the second one. You multiply this 2 by what? The 2 here. So we have 2 by 2. Then 1 by 4 plus 1 by 4 plus 0 by 6. So we have 0 by 6. Now this is a simple multiplication of what? Matrices. So let me take it again. For multiplication of matrices, you can only multiply 2 matrices when they are conformable. Conformable in the sense that the number of columns in the first matrix, which is matrix A, this matrix, should be the same as the number of rows in the second matrix, which is what? Matrix B here. So we have, since we know that they are conformable, forget about their dimensions. In multiplication of matrices, we are looking at conformability. Number of columns in the first matrix has to be the same as the number of rows in what? In the second matrix. So we have first column, second column, third column. Now we have 3 columns here. 3 columns, that's 3C. Let's look at the second one. It has to be the same as the number of rows in the what? In the matrix B. That's the second matrix. We have first row, second row, and what? And third row. So we have what? 3R. So since we've established this, we can now see that these 2 matrices are what? Are conformable. Now that you know that they are conformable, now move straight to your multiplication. And as I said, for the multiplication, we are going to multiply this element. That's the first element, which is 3 by what? By the first one. So we are going to multiply 3 by 1. We have it here. Multiply 3, 1. From there, you move to 3 by what? By 4. That's 4 by 3. We have this here. 4 by 3. Then 6 by what? By 5. We have it here. Now we move to the second what? Element. Now the second element, we are going to use that same rule. Here's the first, so that's 3, 4, and 6. You multiply by what? By the second column of what? Of matrix B. So let me establish this. For multiplication of matrix, we are going to take the first row of the first matrix and multiply by the first column of the second matrix. Let me take it again. We are going to take the first row of the first matrix and multiply it by what? The first column of the second matrix. So it's good by rows and what? Columns. Rows and what? And columns. So as we've established the first item or the first element, we are moving to the second one, which is multiply 3 by what? The first row by what? The second column. So we have 3, 4, 6 as what? Our first row. 2, 4, 6 are what? At our second column in the second matrix, which is what? Matrix B. So 3 multiplied by 2, we have it here. 4 multiplied by 4, we have it here. 6 multiplied by 6, we have it here. Then we move to the second what? The second row. We have 2, 1, 0. So say, as I said, you take the row, you multiply what? By the what? The columns. You take the row, you multiply by what? The column. So we have 2 here multiplied by 1. So 2 by 1. We have 1 here multiplied by 3. We have 1 multiplied by 3 plus we have 0 multiplied by 5. 0 multiplied by 5. Then we move to the second element. So we are going to multiply the second element. That's the result of the second element. We have to multiply the second row of the first column by the second column of the second matrix. That's the matrix B. So we have to multiply by 2 here. We have 2 here. We have 1 multiplied by 4. We have it here. Then we have 0 multiplied by 6. We have it here. After doing this, you then do your addition and what? Multiplication. But then we have to first do the multiplication first. That's doing what is in the brackets. After that, we do what? Addition. So we have 3 by 3 gives us what? 3 by 1 gives us what? 3. Then plus 4, 3, 12. We have 6, 5, 30. Then we move to the second element, which is 2 by 3 gives us what? 6. Then 4 by 4 gives us what? 16. Then 6 by 6 gives us what? 36. Now let's move to the second what? Row. Now 2 by 2 by 1 gives us what? 2 plus 3 by 1 gives us what? 3 plus 0 by 5 gives us what? 0. 2 by 2 gives us what? 4 plus 1 by 4 gives us what? 4 plus 0. So after finishing your multiplication, now you now do your what? Your addition. So 3 plus 12 plus 30 gives us what? 45. 3 plus 12 plus 30 gives us what? 45. 6 plus 16 plus 36 is what? 58. Then 2 plus 3 plus 0 is what? Is 5. Because 2 plus 3 is 5. 5 plus 0 is what? Is 5. We have it here. Then 4 plus 4 plus what? 0 is also what? 8. Now if you multiply the matrix A by matrix B, this is what you have. 45, 58, 45, 58, 5 and what? And 8. That's 2 by 2 matrix. So if you multiply a 2 by 3 matrix by a 2 by 3 by 2 matrix, we are going to get what? A 2 by 2 matrix. Remember our matrix A was what? A 2 by 3 matrix, and the matrix B was what? A 3 by what? A 2 matrix. Now let's look at a second example. We have our matrix A to be what? 3, 6, 1. Then matrix B to be 2, 5, 10. So these are matrix. Then matrix B to be equal to, we have 1, 1, 5, 2, and 2, 7. So find A plus B. And remember, multiplication of matrices is not commutative. We will go deep into properties of matrices in our subsequent videos. But for now, let's look at this multiplication of matrices. We have to find A plus B. As I said, this is a 2 by 3 matrix and what? And a 3 by what? 2 matrix. You can multiply them because they are conformable in the sense that the number of columns in the first matrix, which is matrix A, is the same as the number of rows in the second matrix, which is what? So we have 1, 2, 3, 3 columns, then our 2 what? Sorry, our 3 rows here. So they are conformable. 2 by 3 matrix and 3 by 2 matrix. After multiplying this, you realize that you are going to have a 2 by what? A 2 matrix. So without wasting much time, let's look at it. Multiplication of matrix. Now solution. As I said, we are going to take the first row, which is 3, 6, 1, and multiply by the first column of what? Matrix A. After that, you take that same row and multiply by what? By the second column to get your first row. Then your next step, you take the second row, multiply by the first column to get your item here, that's the second element. Then you take the same row, multiply by the second column to get your what? Your fourth element in order to get your what? Your second row. So now let's go. We have 3 by 1. 3 by 1. Then 6 by 5 plus 6 by 5. 1 by 2. We have 1 by 2. You are done with your first element. Now let's move to the second element. We are taking the same multiply by the second column. So we have 3 by 1 plus we have 6 by 2 plus we have 1 by what? By 7. We are done with the first row. Now moving to the second row, we are going to multiply the second row by what? The first column, then the second column. So we have 2 to be our first element in the second row. So we have 2 multiplied by the first element, which is what? 1, plus 5 multiplied by 5 here. So we have 5 multiplied by 5 plus another 10 multiplied by what? By 2. So we have 10 multiplied by what? 2. We are now with the third element of what? Of our matrix. Now let's look at the fourth element. We are taking the same row multiplied by what? By the columns. That's the second column. So we have our 2 here multiplied by what? Our 1. Then plus we have our 5 multiplied by what? Our 2. So plus 5 multiplied by what? 2. You close the bracket. Then you have our 10 here multiplied by what? Our 7. Now you are done. You are done with the multiplication. So you are done with the first step. Now moving to the second step. You do your multiplication and what? And your addition. So we have here to be 3 by 1 gives us what? 3 plus 6 by what? 6 by 5 gives us what? 30. Then 2 by 1 gives us what? 2. Move to the second element, which is 3 by 1 is what? Is 3. 6 by 2 is what? Is 12. Then 1 by 7 is what? Is 7. Now the second one, which is 2 by 1 is what? Is 2. Plus 5 by 5 is what? Is 25. Then 10 by 2 is what? Is 20. Move to the second one, which is what? 2 by 1 is what? Is 2. 5 by 2 is what? Is 10. Then 10 by 7 is what? Is 70. So after doing your multiplication, now let's look at the addition aspect too. So we have this element. You have element 1, element 2, element 3, and element what? Element 4. So 3 plus 2 gives us what? Gives us 5. 5 plus 30 is what? Is 35. So you have 35 to be our first element. Now let's look at the second element. We have 7 here and 3 here, which is what? 7 plus 3 is what? Is 10. Then 10 plus 12 is what? Is 22. So we have 22 as our second element. Now third element. We have 20 and 25 here. So 20 and 25 is what? Is 45. 45 plus 2 is what? Is 47. Fourth element. We have 70 and 10 here, which is what? 80. Then 80 plus 2 is what? Is 82. 82. So if you multiply this matrix A by matrix B, you are going to have a resultant, which is what? A 2 by 2 matrix. That's 35, 22, 47, and what? And 82. So from this, you can see that multiplication of matrices is not that difficult. Just understand the principle or the concept. After that, you are good to go. Now, let me take you through again. For multiplication of matrices, you can only multiply 2 matrices when they are of what? Conformable. Conformable in the sense that the first matrix, which is matrix A, the columns has to be the same as the rows in the what? In the matrix B, which is what? The second column. So far as your matrices are conformable, that's the number of columns in the first matrix is the same as the number of rows in the second matrix. We are good to go. Now let's see, let's look at this. We have first column, second column, and what? And third column. We have here to be first row, second row, and what? And third row. Now they are conformable. You just multiply. By multiplication, you can make a mistake, but when you are doing the multiplication, please and please, you have to be vigilant. You take your first row, which is 3, 6, 1, and multiply by what? The column. So you are multiplying the rows by what? The columns, and not the columns by what? By rows. So you have your row multiplying by the column, your row multiplying by what? The column. So first row multiplied by the first column and the second column. Second row multiplied by the first column and the what? And the second column. Then from there, you are good to go. In the next video, we are going to do application of what? Matrices in business, where we are going to solve complex matrices application, that's in business. What? In business. So we are going to use this what you've learned in this particular video to do what we are going to do in our next video. Now, this is the end of our lesson. If this video finds you helpful, kindly please like, subscribe, and share it to your friends. If you have any suggestions or anything to say, kindly write it down in the comment section. Thank you.